Today I'm going to explain how we perform and understand the LogMar visual acuity test, step by step, just as we would in a clinical or teaching setting. First, remember what LogMar actually means. LogMar stands for the logarithm of the minimum angle of resolution. In simple terms, it tells us how small a detail the eye can resolve, measured in minutes of arc, and then expressed using a base 10 logarithm. This system is more precise than Snellen and allows results to be averaged and compared reliably, which is why it is widely used in clinics, research, and low vision assessment. When you conduct a LogMar test, the patient is seated at a fixed test distance, usually 6 meters or 20 feet. This distance must be accurate, because all the letter sizes on the chart are calculated based on it. The chart is well illuminated, and each line has the same number of letters, with equal spacing between letters and between lines. This uniformity is very important and is one of the key differences from the traditional Snellen chart. You test one eye at a time, with the other eye properly occluded. If you are measuring best corrected visual acuity, the patient should wear their glasses or contact lenses. Ask the patient to read the letters from the top of the chart downward, and encourage them to attempt every letter, even if they are unsure. Unlike Snellen testing, guessing is allowed because scoring depends on the total number of letters read correctly. Each line on a LogMar chart represents a change of 0.1 LogMar units. As the letters get smaller, the visual angle decreases in a very regular, logarithmic way. If a patient loses one full line, their LogMar score increases by 0.1. If the visual angle doubles, that corresponds to a 0.3 increase in LogMar, which is equivalent to losing 3 lines on the chart. Scoring can be done line by line or letter by letter, depending on the chart used. In basic teaching, we often explain it line by line. The top line usually corresponds to a LogMar value of 1.0, and the 20/20ths line corresponds to a LogMar value of 0.0. Values better than 20/20ths are written as negative LogMar values, such as -0.1 or -0.3. Now let's connect this to Snellen visual acuity, because conversion is a common exam and clinic question. To convert a Snellen score to LogMar, you first take the reciprocal of the Snellen fraction. For example, if the visual acuity is 2200, you divide 200 by 20, which gives you 10. This value represents the minimum angle of resolution relative to normal vision. Next, you take the base 10 logarithm of that number. The logarithm of 10 is 1, so a Snellen acuity of 2200 corresponds to a LogMar value of 1.0. If the patient has a Snellen acuity of 20/20ths, the reciprocal is 20 divided by 20, which equals 1. The base 10 logarithm of 1 is 0, so normal vision corresponds to LogMar 0. If the patient has better than normal vision, such as 20/10ths, the reciprocal is 10 divided by 20, which equals 0.5. The base 10 logarithm of 0.5 is approximately -0.3, giving a negative LogMar value. Clinically, always remember how to interpret the result. Lower LogMar values mean better vision, and higher LogMar values mean poorer vision. A change of 0.1 is clinically meaningful, representing one line difference. This precision is why LogMar is preferred for monitoring disease progression, treatment outcomes, and visual performance over time. So, when you perform a LogMar test, focus on correct distance, proper illumination, encouraging the patient to read every letter, and understanding how each line and each score reflects the minimum angle of resolution in a clear, mathematical way. Follow and subscribe Optometry Skills to help us create more educational videos. Thanks for watching.